Welcome to 29th lecture. We are studying circuit analysis. Today we'll solve an example related to Thevenin's theorem for AC circuits. We have already studied Thevenin's theorem for DC as well as AC circuits and have solved a number of examples. This lecture gives us a chance to practice on another sample question related to AC circuits. The steps are already known to us. Number one step is that we have to remove ZL, the load impedance. Here we have this minus J1 ohm as load impedance CL. So in first step we'll remove it. Number two, we'll find VOC or Thevenin across open ends. When we will remove it, we will be left with two open ends right here. We'll find voltage drop across these two ends, which we call as VOC or Thevenin. OC stands for open circuit. In step number 3, we'll find Thevenin. To find Thevenin, we'll replace current sources with open circuits. Current sources with open circuits and voltage sources with short circuits. Number 4, we'll draw Thevenin's equivalent circuit and we'll find the unknown quantity by putting back the ZL that we removed in step number 1. So let's solve this step by step. Step number 1 is remove ZL, which we have already done. In step number 2, we'll have to find VOC or Thevenin across these open ends. Right. We can find out the value of Thevenin either by applying nodal analysis or loop analysis, but we feel that applying loop analysis is more appropriate because we assume two loops here. In step for loop number 1, the current is already known because we have a current source in this loop, and we have already studied that if there is a current source in a loop, we don't write KVL equation for that loop. We assume that current positive if the direction of that current source and our assumed current are the same, and negative otherwise. And for this loop number 2, we'll write KVL equation through this 1 ohm resistor. We have two currents flowing, I2 flowing upwards, I1 flowing downwards. So I1 will be negative because we are in loop number 2. We'll write I2 as positive. Plus J1 through this J1 ohm inductor, we have only one current, I2. Plus through this 1 ohm resistor, we have only I2 current flowing is equal to 0. So now we have this as equation number 1 and this as equation number 2. We can straight away put the value of I1 here, 10 at an angle of 0, and then we'll be left with only one equation and one variable, and we can solve for I2. I have done all this calculation in my notes, and we finally reach by solving this equation through some simple mathematics. We reach 2I2, which is 10 over square root of 5 at an angle of minus 26.5 degrees. For the intermediate mathematics, you refer to my notes. Right. Now we'll assume a voltage V1 here. The voltage V1 with respect to this ground is the voltage drop across this 1 ohm resistor, which is V1 is 1 times I2, which is the same as I2, 10 over square root of 5 at an angle of minus 26.5 degrees. Now, VOC or Thevenin is the voltage on the positive side of this voltage source. The voltage on the negative side of this voltage source is this. So what should be the voltage on the positive side of this 10 volt source? Of course, the voltage at its negative end plus its magnitude. 10 over square root of 5 at an angle of minus 26.5 degrees plus 10. So the voltage at the positive end of the voltage source is the voltage at its negative end plus its own voltage. Solving this gives us VOC or Thevenin is equal to 14 minus J2, which is VOC, which is also Thevenin. So now we have computed Thevenin or VOC as a result of applying a technique, loop analysis technique, and this concludes step number 2. In step number 3, we have to find Z Thevenin. To find Z Thevenin, we have to find the voltage. We have to find Z Thevenin here. All voltage sources will be replaced with short circuit. This is a voltage source. We'll replace it with a short circuit. This is a current source. We'll replace it with an open circuit. And now this is the stuff for which we have to find Z Thevenin. To find Z Thevenin, we see this 1 ohm and J1 ohm are in series, open circuit from here. So this 1 ohm comes in series with this J1. This whole impedance is in parallel with this one. This parallel combination is solved as we have been doing it for DC circuits. This is R1, this is R2. If it is mapped on a DC circuit, in a DC scenario, we write it as R1 times R2 over R1 plus R2. But here we have impedance is Z1, Z2. So we write Z1 times Z2 over Z1 plus Z2. 1 plus J1 times 1 over 1 plus J1 plus 1. Z1 times Z2 over Z1 plus Z2 gives us 1 plus J1 over 2 plus J1. So now we are ready to perform step number 4, drawing Thevenin's equivalent, because we have computed OC or Thevenin, and we have also computed Z Thevenin. So the equivalent is now this step number 4. This equivalent is a voltage source having magnitude 14 minus J2 volts in series with an impedance having value 1 plus J1 over 2 plus J1 ohms, and we put the load impedance back, which is CL, which we removed in step number 1, minus J1 ohms. We have to find voltage drop across it. To find this voltage drop V out, we'll apply voltage divider rule. Apply voltage divider rule, find V out. V out is the impedance ZL divided by the sum of the two minus J1 plus this 1 plus J1 over 2 plus J1. This is the Thevenin. Multiplied by this voltage 14 minus J2. This volts. To solve this expression and to find the numerical value of V out is left as a homework for students. Homework is to find numerical value of V out. This is all for this lecture. In this week, I'll solve one or two more questions related to AC circuits. Thank you.